We're going to look at trig identities. An identity is an equation where it's true for all values of x. Sometimes when you look at identities we use 3 equal signs instead of just 2 to show that it's exactly equal to. The first identity we're going to look at, consider a right angled triangle. Give one of the angles the name x, and therefore the angle at the other side must be 90 minus x degrees. Labelling the sides A, B and C, I can see that sine of x is equal to A over B. By the same method, cos of 90 minus x, the other angle, is also equal to A over B, because cos is adjacent over hypotenuse. So that tells me that sine of x is the same as cos of 90 minus x. There we have what we call a trig identity. If that's true, then therefore it's also true that cos of x is equal to sine of 90 minus x. Those are your first identities. The second of our basic identities, let's go back to considering the same triangle again. So we've got a right angled triangle, sides A, B and C, one angle x degrees. I can see from this triangle that tan x is equal to A over C. Also, cos x is C over B, and sin x as A over B. Using these fractions, these ratios of sine, cos and tan, I can manipulate them so that I can see that A over C is the same as A over B times B over C. Think back to when we did rates of change and related rates of change. The same idea applies. Where do those come from? Well, A over B, we've just said, is sin x. B over C is cos x, but inverted, so 1 over cos x. So therefore, A over C is equal to sin x divided by cos x. That gives us the identity of tan x, which was A over C, is equal to sin x divided by cos x. And that's our second identity. For our third identity, I'm going to use the same thing again. I've got a triangle, label angle x, two sides A and B. Just this time, I'm going to call the third side the length of 1. So, looking at those ratios, sin x, I can see it's A over 1, which is just A. Cos x is equal to B over 1, which is just B. Thinking back to Pythagoras for right angled triangles, I can see that A squared plus B squared must equal 1 squared, 1. So substituting those things back in again, if sin x is A and cos x is B, I can write that equation as sine squared of x plus cos squared of x is equal to 1. Notice that when we write sine x squared or sine squared x, the squared goes between the sine and the x, not at the end, so it doesn't look like sine of x squared and isn't confusing. That's our third and final of our basic identities, sine squared x plus cos squared x equals 1. Those 3 basic identities are used to derive a whole load of other identities that we'll look at next.